Good afternoon. So I will tell you something about the biogeophysical effects from land cover changes in Europe. So now we're only restricted to those effects. So we know that land cover changes will have an effect on the climate, so the biogeophysical effects. But we don't know that much about it. So actually, we don't know how big it is, and actually we don't even know the sign of it, at least in some parts. And the size of this effect is comparable to the greenhouse gas forcing. So it is something that we actually should consider. Most previous studies are made with global models, and in them, usually the albedo effect is the important effect. So they don't consider or take into account, for example, changes in heat fluxes. So there is also a need for higher resolution. So we've seen this before, but in short, we have the difference between forests and open land. And forests have low albedo and high evaporation, and open land have high albedo and low evaporation, just to simplify things a bit. So if we, for example, remove forest, so in the case of deforestation, we get higher albedo, which then would give lower temperature, and we get less evaporation, which then would get higher temperature, and the other way around for afforestation. So it's not clear here what the effect will be if we do such changes. And to do this, to my help here, I have these two guys, so two models. RCA4, that's the Rossby Center regional model, and HCLIM, that is the harmony model in climate mode. And both these models use the same forcing here, so both are driven by area interim data for 91 to 2010 after 1 year spin-up. And they use the same land cover fields, so eco-climate fields that are some way modified then. So the only difference here is the models. So I have three setups. So the first one is control. So this is the present day actual condition. And what we see here is a fraction of forest. So in Scandinavia we have lots of forests, so here it's close to 1. In continental Europe we don't have that much forest, but there are some regions with quite a lot at least. And then there are these two afforestation and deforestation simulations, and they are highly idealized. So in the afforestation simulation, I use potential vegetation, and that means that the vegetation is allowed to grow freely without any human intervention. So you can see that in the regions here with no forest, we have a change of 1. So we almost have forest everywhere. So in some regions, vegetation is limited by moisture, for example, so we don't have, so you can see here, for example, we don't have a full forest cover, but almost. And then in the deforestation case, then all forests are removed. So in that case, we don't have any forest at all, nowhere. So these are, I mean, this is very extreme, but it's to set the outer limits of what the size of the effect, what we can expect. And then to go to some results. So now we have results from RCA to the left, and HCLIM to the right, and then winter, summer, winter, summer. And this is for the deforestation scenario. We can see that there are some common features. So in the winter we see it's colder in the north and the east. That is well, it's clearly the albedo effect. So when you remove forests, the ground is more easily covered by snow. But you can also see that, especially in summer, we have totally different signals here between the two models. And if you also look at the afforestation simulation, so now again RCA to the left and H-claim to the right, we see that we have completely different signals. So the magnitude of the change is about the same, but the sign is completely different. And that, of course, poses some interesting questions. So why is that? And I will try to well, get into this and understand it a little bit more, and focusing on the afforestation simulations. So if we start looking by what's happening with the albedo when we do these changes, we can see that the change in albedo in these two models are, well, not exactly the same, but very similar. And that is, I mean, in some way to be expected. So we know the albedo of the forest, we know the albedo of open land. So it should be about the same. So this is not the reason for the differences between the models. But if we, on the other hand, look at evaporation, and now we can concentrate on summer, because in winter evaporation is kind of small, so it doesn't really, and these are changes in percent. So, but then we see that in RCA we have more evaporation with afforestation, and in HCM we have less evaporation in the afforestation simulation. And this, I mean, this seems a bit strange, you can think, and right now I'm not going to judge and say which one of these I think is the best, but you can do that yourself, of course. But there are some, if you look into the code, you can see that there are some differences here in how this is parameterized in the models. So how the model responds in evaporation to changes in vegetation. It's not that simple that more more vegetation or forest will give you more evaporation, because how this is described, it is so that open land or grassland, it can evaporate freely without any limits, while the forest can hold back, so the vegetation is not completely dried out. So that can be one explanation for this. And of course, if you look into this, you can also see how is the evaporation in the control simulation. You can see that actually in the southern parts of Europe, evaporation is much higher in HCLIM than in RCA. Yeah, so that was quick, but so a few conclusions then. So the effect of afforestation and deforestation is large. So it's in the order of RCP 2.6, so about 2 degrees in the end of the century. So it's something that you have to consider, actually. The biogeophysical effects, they depend also on regional characteristics. So you can't just say that afforestation will give you a higher temperature or lower temperature. But if you look closely, for example, here you can see that the same amount of change in vegetation can give increasing temperature in some part and decreasing temperature in another part. And this is because of the characteristics of the region. So is there soil water available that can be evaporated, or if it's not any available, then you won't have any, if it's a very dry region, you don't have that big of a change in evaporation. So then the albedo effect will be the important effect. And as we see here, the results are highly model dependent. So to you as modelers, this is, well, I can come with a warning here. So be careful when you're doing this. Look at one more model if you can. And, well, even after this model exercise, the biophysical forcing is still to be better constrained. So we don't get any clear answers from this. So is the sign positive or negative? And some practical implications of this. So, for example, afforestation as a mitigation strategy. So if you forest regions to bind CO2, that may have some effects on the regional climate that may not be the same that you want. So it's highly uncertain when it comes to the regional climate. And the same, of course, goes for if you want to increase croplands for growing biofuel. So what will be the effect of larger croplands in Europe because we want to have more biofuel production, which is also part of RCP 2.6, actually. So that is also something to think about for the future. So, yeah, thanks.
Thanks very much, Gustav. Yeah, we know that one is climate modelers and regional downscalers. Are there any questions? Very interesting talk. Natalie.
Yeah, thank you for your talk. I think it echoes what we already know from the lucid experiments at the global scale and from the recent paper from Yan Li that shows that in fact the sign depends on the change in shortwave and the change in evapotranspiration. The question now is how do we move forward and what do we do in terms of validation? Because behind this you probably have soil moisture. If you've got enough soil moisture, then you will go in one direction. If you don't, you will go in another direction. So I think it's good to show the same things, but now how do we move forward and how do we change that? So do you have suggestions, or what are you going to do to improve that?
I don't really have any. I mean, up to this point, I can just. I mean, we can just settle on the fact that this is how far we get. But I guess observations is always a key for validation. I mean, it's simple to say. It's not that simple to actually do it, but.
It's nice to hear that observations are also an issue in Europe. Can we go to yourself, then the lady next to you after you?
So Gustav, just a short question. Can you comment on the variables which are affected, on the parameters which are affected due to the afforest or deforestation you made? So it was not only albedo, but also leaf area index roughness.
Yeah, right. What is changed when we change the vegetation is leaf area index, roughness, root depth, and I think also the root characteristics in some way. I think those are. I might have forgotten something, but.
If you mentioned evaporation, then do you mean evapotranspiration or bare soil evaporation?
I mean evapotranspiration. Yes. Sorry. It should.
And the last question over here, thank you.
Yes. You said the RCA4 give higher evapotranspiration. Higher.
It depends on where you look. So roughly in Northern Europe, both models are about the same. In Southern Europe, RCA gives less evaporation than HClean in the control simulation.
Yeah, this is my question. Is the control give you less evapotranspiration?
it gives me less than the other model. Okay, sorry. So, yeah, I mean, yeah, but this is compared, so this is if you compare the authorization simulation with the control simulation. But if you, in the control simulation, compare the two models, so that's another thing. So which of these models give the most evaporation in the control simulation?
The second question, I mean, what methodology was used, I mean, in both models to estimate evapotranspiration? Maybe the difference due to the methodology used to estimate.
Do both models arrive at evapotranspiration in the same way?
Yes. Yeah.
Okay, so there's...
Yeah, more or less. But then, of course, the difference is in how the models calculate that. So that is why you get. So you can't say. I mean, if it was the same, then you should get the same results. So.
Okay, we're going to have to stop there. Thanks for a really interesting talk. We're gonna